morning, sir. Mahina lang po.
Okay, so today we will discuss on the continuation on our hydrostatic force. So, hindi ko siya sinabi doon sa ating midterms. If na-observe niyo doon, sa last semester, sinali ko siya kasi marami kaming time doon para ma-discuss to. Kasi itong lesson ito is more complicated. So, I will be adding this to your hello, may na pa ba? Or narinig na? Putol-putol. Kaya about this, rinig na? Pag nag-charge pala. Okay. So, our lesson for today is continuation on our hydrostatic force. So, let me share to you with my screen. Ay, kita yung screen? Hindi pa?
Kita po.
Okay. So, if yung naalala nyo yung last lesson natin, that is hydrostatic force. So, we are just solving on the value of F and the location of that force. So, what if we had another force dun sa ating gate? Okay, so hindi lang yung hydrostatic force yung nag-act dun sa ating gate. So, meron pang mga tinatawag nating mga forces sa ating supports or what we call the vertical forces, horizontal, and the moments acting on that gate. So we will apply this subject para siyang yung deformables ninyo. So pinaghalo natin sa fluid mechanics. So let's have a review first dun sa ating, or sa static siguro na discuss to, sa ating mga types of supports. So we do have rollers. Are you familiar with this one, di ba? Familiar kayo nito? Okay, so when we say roller, pag sinusuportahan natin ng roller ng isang gate, there will be one support. This will we call as our FY or the vertical support. Next, pag pinned or hinged, there will be two supports, the FY and the FX. Next, yung ating fix. Sa fix naman, meron din tayong F of Y, F of X, and a moment of support. Next, if that is simple frictionless support or the stoppage, we will also have one support or we call Fy kung nasa vertical siya na axis. Kung horizontal naman, we call it F of X. So, depende sa kanyang line of axis. So, ito yung example ng fixed support sa ating real-life setting. Ito yung fixed support. Ito yung hinge or rollers, hinge or pinned. So, makikita nyo din siya sa ating mga doors. That is why it is called hinge. So, dalawa yung sinusuportahan nito. The F of X and F of Y. Forces sa X and forces sa Y. Next is yung ating roller. So, isang support lang sa vertical. And lastly, we have the this one is the the simple frictionless support or surface. If nakikita yung bridge sa balagtas, so ito yung tinatawag na simple surface or simple support. Okay? Yan yung ibig sabihin ng mga support natin, types of support. So how do we apply this one to our subject? Since, di ba, sa ating hydrostatic force, yung ating sinasolve lang doon is yung value ng F or yung hydrostatic force, and also the location of that force. So what if may meron tayong mga support dun sa ating hinge? So meron na tayong mga summation of forces on the vertical and the horizontal. Kasali din yung moments. So for example, this one, if we have this force here vertical, and we also have the force here upward, and then we take moment at A, right? So we sum up all the vertical forces and the moments to take moments. So moment is force times the D, and D is the lever arm. Okay, so this force, as we take moment at point A, ang kanyang lever arm or distance is this one. Okay? Next is this force over here, and kanyang moment is from the from point A up until the point B. Okay? So yun. So as we take moment, we do have also a convention. So convention tayo ng pa counterclockwise or going to the right, that will take as our positive moment. So at point A, dito tayo kukuha ng moment. So say for example, this force over here, pag nakuha niya, pag nag-take tayo ng moment at point A, yung rotation niya is pa counterclockwise. Kaya ito ay positive, right? Positive times the lever arm, which is 3 meters from point A. Okay, this RB here, or ba't wala ang kulay? Ang kanya namang force pa A is pa ganito, that is clockwise, right? So meaning magma-minus siya dahil tayo ay positive on the right side or the counterclockwise side. So this is RB, or reaction at point B, times 6, since it is 6 meters from point A. Plus there is another moment at the edge. So this is positive, since this is counterclockwise, positive 15, and this moment is 3 plus 3 plus 3, which is 9 meters from point A. So ay hindi pala, may ano na pala siya, may distance. Okay, so minultiply na yung force dito sa distance, so that is 15 kilonewton meter. Since yung moment dito is it's either kilonewton meter or newton meter, or that is pound force feet. Okay, so summation of all moments, makukuha natin yung reaction at point B. So yun, konting review lang on how to take moments and to find the value of our lever arm. So yun yung importante. So as you can see, this RAH and RAY, this is the what we call the hinge. Okay, so naka-hinge siya, or hinge ba tawag nito? Oh, hinge siya. Nandito may support ata to originally. So dalawa yung kanyang support. So that is f of y and f of x. So tinawag siyang RAY and RAV, or the reaction at the vertical point A and the reaction at the horizontal at point A. So kung isasalin natin siya sa moment, since nasa point A siya, so ang RA magkakaroon ng positive RAB times 0. So kaya hindi na siya sinali, pati yung RAH. So positive RAH times 0. Kaya hindi na din siya sinali dito sa ating computation, since nag-act siya doon sa point A, where we take moment at point A. So wala siyang lever arm. Okay. So let's see kung ano yung mga application natin sa sinosolve natin, kung ano ba yung mga sinosolve natin. So actually ito yung parang ito yung sa real life setting kung bakit tayo nagsosolve ng hydrostatic force on dams, and sa mga type ng yung mga iba't ibang klaseng shapes ng ating gates sa dams. As you can see, meron tayong square, meron din tayong curvature. Okay, may iba't iba pa. Usually wala yung triangular na shape ng gate, meron tayong circular. Okay, so yung triangular lang ay tinetest lang yung ang kung alam niyo yung theory ng pag-solve ng hydrostatic force. So ito yung application natin kung bakit tayo nagso-solve ng hydrostatic force. Again, the hydrostatic force is caused by the force of the water. Bakit may force ang water kahit static siya, kahit hydrostatic? Tinatawag siyang hydrostatic force because there is a force but the water is at rest because of the weight. Okay, gets yun? Dahil may weight yung tubig, kaya nagkakaroon tayo ng hydrostatic force acting on the gate. So, meron siyang, may nagpo-push dito sa gate natin. That is what we call the hydrostatic force. And the location of that hydrostatic force is below of the center of gravity or what we call the center of pressure of the gate. Gets yon? Okay pa ba? Parang
Okay po.
okay. So, please answer may ano po. Parang hindi po ako parang tanga dito na nagsasalita na walang nasagot. Gets yun?
Yes, sir.
Gets po, sir.
Okay, let's have an example on first example. So again, yung sinusolve lang natin last time is the value of F or the hydrostatic force and its location sa gate. So what if dinagdagan natin ng puwersa na P and then meron tayong naka-hinge na A? So how do we solve this type of problem? Since marami na siyang forces acting on the gate. So dapat ay master nyo na yung pag-solve ng hydrostatic force and its location. Teka lang Okay, kita na ulit yung screen. Wala.
Yes po.
Okay. So a fish pond gate is fixed 6 feet wide and 9 feet is hinged at the top and held closed by water pressure as shown in the figure. What is the horizontal applied at the bottom of the gate is required to open it. Neglect the weight of the gate. So, ano yung pwersa na kailangan dito sa P para ma-open yung gate natin? Since yung force na to is galing sa ating tubig, that is what we call hydrostatic force, meaning there is a force kahit naka-static lang yung, naka-rest lang yung tubig because of its weight. So, meron tayong pwersa na P or the stoppage. And then yung hinge natin, sinabi dito, that A ano yan, is hinge at the top. Okay? So meaning this A here is hinge. So ilang ilang support dito, ilang support forces pag naka-hinge? Dalawa, di ba? That is A sub X and A sub Y. Ang support na A sub X is pinipigilan niya ditong pwersa sa tubig, and yung AY is yung support na nagsusupport dito sa concrete or itong box na to. So, ito yung support sa A sub X, ito yung support sa A sub X and A sub Y. So, yun yung magiging free body diagram natin. Ito yung mga horizontal forces, and then ito yung vertical forces. So, let's try to draw this gate in a more imaginative way. Okay? This is the concrete, and then i-3D natin yung gate para makita nyo talaga paano kayo mag-solve ng hydrostatic force, kasi hindi kayo masyadong based sa exam natin, hindi nyo pa nagigets kung paano mag-solve ng hydrostatic force. So this gate here is 6 feet wide, so meaning this is 6 feet, right? 6 feet, and then that is 9 feet of height. Gets ba? Ito yung tubig, dito yung gate. Okay. So next, ang first natin hahanapin is yung value ng F. So how do we solve for the F? So this is 8 feet, right? 8 feet. So F is specific weight times the H bar, or the distance from the surface to the centroid of the gate, vertical, times the area of the gate. So the specific weight, that is the specific weight of water, 1 times 9.81. Maiba din dun sa exam, hindi na binigay ko yung specific weight, hindi na nakita. So this is this is in feet, so this is 62.4 pound force per feet cube. Yun, that is the specific weight of the fresh water. So H bar, paano natin makuha yung H bar? From the surface to the centroid. So since this is 8 and this is 4.5 feet, right? So 8 plus 4.5. So H bar is 12.5. Gets yan?
Opo.
12.5 times area ng rectangle, that is 9 times 6 feet. So ating hydrostatic force is 42,120 pound force. Yun. So ito yung pagsosolve ng ating hydrostatic force. So next is yung location ng force dito sa gate. So how do we find it? Since this is CG, this is CP, dito yung mag-a-act yung F natin. Iisan natin ang kulay. Dito sa CP. So let's try to find first the value of E. Okay? E is BH cube over 12 over area times H bar or Y bar. Since this is vertically submerged, H bar is equal to Y bar. Since hindi siya naka-inclined, okay? Same lang yung value ng H bar tsaka Y bar. So, ito yung original formula natin, di ba? So, pwede ko siyang itaas since that is equivalent lang naman, area times H bar. Okay? So, tinaas ko lang yung area times H bar. So, the value of base here is 6, right? 6 feet times the height, that is 9 feet cube. over 12 times area of the gate, that is 9 times 6. May naka-on ng mic.
Saka ito nakalagay din yung formula ng
Okay. H bar here is 12.5. Okay, so the value of E here is 0.54, or the eccentricity. Eccentricity is the distance from the centroid to the center of pressure. So we can now find the location of our F, which is 0.54 from the CG. Okay, so let's try to have another free body diagram on the forces acting on the gate. Okay, so ito yung gate ha. Ito yung hinge. Again, the hinge will support A sub X and A sub Y. Ito yung support system ng hinge, dalawa. Pag roller, isa lang. So this is the gate. This is our CG. And this is 9 feet, right? CP. And we all know that CG and CP is 0.54. So, kailangan natin kunin yung value ng force P. So, ang F ay nandito, right? Yan. So, kailangan natin kunin yung force P since meron na tayong value ng F. So, we need to take moment at point A para makuha natin yung forces sa P. So, kailangan muna nating alamin yung lever arm nila. Ang P natin, no problem since nasa bottom siya, meaning that is just the height of the gate. So, 9 feet from the point A, or point where we take moment. So, ang F naman natin is CG, which is half of 9, 4.5, plus the E. So, this is 4.5 feet plus E, 0.54. So, that is 5.04. So, 4.5 plus 0.54. Gets yon? So, that is his lever arm. Okay, naintindihan pa ito na part. This is just the height of the gate. Half is CG. So half of it is 4.5 plus the E, 0.54.
Gets po, sir.
Okay, so take moment at point A kasi doon natin makukuha yung force P. So we take moment at point A equal to 0. So our convention, positive for counterclockwise. So as you can see, yung mga AX and A sub Y, take moments dun sa A, magiging 0 na yon, di ba? Kasi ang kanilang forces is andun sa point A. So ang lever arm niya is automatic 0. So hindi na siya pwede na nating i-cancel yan, magiging 0 na yan. So the forces at point A, this one will take moment to the point A, so pa counterclockwise. Ang P naman will take moment at point A pa ito pala ay clockwise, then ito ay baliktad. So ito ay clockwise and then ito ay counterclockwise. So ang P papunta dun sa point A, ganun yung direction niya, clockwise. Ang F naman, dito yung kanyang direction ng moment, so pa counterclockwise. So F is positive since that is counterclockwise. Positive F. Gets ba? Times the lever arm niya is 5.04 feet. That is 5.04 from point A. Okay, next is yung P natin, which is negative kasi clockwise siya, minus P. Ang lever arm niya from point A is 9 feet. That is equal to 0. Okay, yung value ng F natin is meron tayo, di ba? 42,120 times 5.04. Okay, lipat na lang natin yung P sa transpose natin, 9P. P times 9 is 9P. Divide lang natin ng 9, makukuha natin yung P. So, P is 23,587.2 pound force. Okay, so ito lang naman yung hinahanap dito, the horizontal force at the bottom of the gate. So, meron na tayong F and meron tayong P. Masasolve din natin yung value ng A sub X and A sub Y by summation of forces at X and Y. So, we will encounter this part on the next example. But so far, nagigets ba yon? Ito?
Gets po.
Okay, ulit. Another problem. Gate AB, this is AB, is 5 feet wide. So, 5 feet wide, as you can see, or 5 feet wide. Ito. Hinge at point A. So, ang A na yan is naka-hinge. So, dalawang support yan. And restrained by a stop at point. So, ito yung tinatawag na stoppage or the smoothless support. Or isa lang yung support niya dito. Sinusuportahan niya yung kina-counter niya yung hydrostatic force. Tatawagin nating B. So this is A sub X and this is A sub Y. Since naka-hinge siya, so dalawa yung support. So compute the force on the stop or the B and the components of A, which is the A sub X and A sub Y, if the water depth is 9 feet. This is 9. Neglect the weight of the gate. So let's neglect the weight of the gate. So meron pa tayong weight kasi dyan. So sabi niya, neglect this one. So hindi nakasali yung weight sa ating pag summation of forces mamaya. So let's draw again. So this is the gate. It says here that this is 9 feet. Okay, and the gate here is 3 feet. And the width of the gate is 5 feet. So this is the centroid. Therefore, this is 6 feet. So first, we need to find the value of F. So mag-a-act ang F dito. So how do we find the value of hydrostatic force? F is equal to the specific weight times h bar times area. F is equal to specific weight is, this is water. So 1 times 62.4 pound force per feet cube. H bar, how do we find h bar? Since this is 6 and half of 3 meters, so h bar is 6 plus 1.5. So that is 7.5. Pa yun? 7.
Opo.
Area of the gate is 3 feet times 5 feet. 3 times 5 or 5 times 3. Since rectangle lang yan, length times width. So the value of our hydrostatic force is 7,020 pound force. Next is the location of our F. So to find the location of our F, kailangan natin yung eccentricity. Since siya yung magiging standard natin para malaman kung saan siya naka-position from the centroid. So that is BH cubed over 12 times area times H bar. H bar is equal to Y bar since that is vertically submerged. So pag naka-inclined, yung H bar and Y bar is different. E is equal to the base of the gate, that is 5 feet, times the height of the gate, 3 feet cubed, equal to 12. Area of the gate, 5 times 3 times H bar, which is 7.5. So E is equal to 0.1. Okay, so let's draw another P-body diagram. So this is the gate, this is point A, and point A has A sub X support and A sub Y support. And this is 3 feet gate natin. This is the P. Shit. Alis. Pa lang po. Sorry po, may pusa lang po. Okay, nakikita pa yung screen?
Yes po, sir.
Sorry po, may pusa lang po nakaano dito. So again, this is the value of P, and the gate is 3 feet. And our hydrostatic force is here below the CG. Okay, so this is CG. CG is half of 3 feet, which is 1.5 feet. So 1.5 feet plus E, 1.5 plus 0.1, that is 1.6. Gets ba yun? Bakit naging 1.6? This is half of 3 feet, 1.5 plus 0.1, that is 1.6. Okay tayo doon?
Opo.
So summation of force moment at point A equal to 0. So dito tayo magte-take ng moment since kukunin natin first yung value ng P. So ang convention natin positive pag counterclockwise. So ano yung mga counterclockwise dyan? Yung F or P. So you can see if we draw the rotation sa F, pag ganyan, counterclockwise. Ang P, pag ganyan, towards the point where we take moment. So, magiging clockwise ang P. So, ganun din kanina. So, that is, again, yung AX and AY, 0 na yan since yung lever arm niya is 0 from point A. Ang F natin is positive since that is counterclockwise. So, F times 1.6. Okay, minus B pala to. So, B times 3 feet from point A. Okay, F natin is 7,020 pound force times 1.6. Okay, lipat na natin yung B sa kabilang side. Magiging positive 3B. Divide lang natin ng 3. So B is equal to 3,744 pound force. Okay, ito pa yung first natin kukunin, B. Next, sinabit pa kasi niya, compute the force on the stop, which is yung B, and the components of reaction at point A. So, since naka-hinge siya, so dalawa yung components of reaction, AX and AY. So, how do we find AX and AY? By summation of horizontal and vertical forces. Since may value na yung B natin, makukuha natin to using vertical and horizontal force summation. So again, yung convention natin pag vertical forces, positive ay pwedeng negative, positive yung ano ba? Ano na lang, downwards natin is positive. Pwede namang positive yung upwards niya. Depende kayo doon. Depende sa inyo. F sub x naman natin is 0. Yung ating positive is on the right side. So again, you can just replace your convention. Magdedepende kasi yun sa sign ninyo. But the answer will still be the same. So as you can see, yung ating vertical forces doon is W, and then sinabi niya yung weight ng gate is to be neglected, so W is 0. Diba? Next is yung A sub Y. Diba? A sub Y lang yung vertical dito. So that is minus A sub Y. Since yung convention natin is pababa is positive, and then yung AY is pataas. Again, bakit naging positive bakit pataas yung A sub Y? Sinusuportahan kasi niya yung weight ng concrete or nito. Yung A sub X is pa left because sinusuportahan niya yung puwersa ng F or puwersa ng tubig or hydrostatic force. So yun, magiging minus A sub Y kasi pataas yung A sub Y equal to 0. Therefore, A sub Y is equal to 0. Okay. Next is yung F of X, summation of horizontal forces. So, pa right side positive. So, ang right side lang na natin is yung F, right? The other horizontal is pa left na. So, ang AX is pa left, kaya minus. Ang B naman natin is pa left, kaya minus din. Ang F, meron tayong value, 7,020. Right? Ang A sub X, ito yung hahanapin natin. And ang B natin is, this is 3,744. So therefore, pag nilipat natin yung A sub X sa kabila, A sub X is magiging positive, tapos 7,020 minus 3,744 is 3,276 pound force. Gets to?
Gets
Clear po, sir.
Okay. So, next example is dalawa na yung hydrostatic force natin on the left and the right side. So, may water sa left side and may water din sa right side. So, ganun din. Let's draw. So, yung gate lang is 5 feet width. So, both sides, yung gate is 5 feet. So, let's draw the free body diagram first. Yung first. Unahin natin yung sa left side na hydrostatic force. Since may water sa left side. Let's draw that gate. So, this gate on the left side. This is 3 plus 4, so that is 7 feet. right? And this is 6 feet. Kukunin muna natin yung H bar para hindi na tayo mahihirapan dun sa ating hydrostatic force at F1 or on the left side. So this is, wait, kukulayan natin. So H bar natin is, palagay nyo, ano yung H bar natin? 6 plus 7 over 2. That is 9.5. Okay. So the F1 here, or the hydrostatic force at the left side, is specific weight times H bar times the area of the gate. So F1 here is specific weight, that is water ba? Okay, water. 1 times 62.4 pound force per feet cube. H bar is 9.5 feet times area of the gate, that is 7 feet, and ano nga yun? Width is 5 feet. Okay, so ating hydrostatic force at the left side is 20,748 pound force. Okay? Next is yung ating location ng F using E. Malalaman natin yung location niya. So that is BH cube over 12 area times H bar. So again, H bar is equal to Y bar pag inclined, pag vertically submerged. So base natin is 5 times height natin is 7 cube over 12 times the area of the rectangle or the gate, that is 7 times 5 times H bar, which is 9.5. So E is equal to 0.4298. Okay, so ang hinahanap pala dito is yung value ng N. Okay, so let's try to draw first the second, or let's solve first the second hydrostatic force on sa right side. So sa right side, so again, this is, ang gate sa right side is 4 feet lang. Ano ba? So this is 4 feet. Ito yung gate sa right side. So fully, ano siya? Ano pala siya? Full. So bali ang kanyang water surface is nandito. This is 5 feet again. So ang H bar natin is half of the length, which is 2 feet. Since yung tubig ay nasa top lang ng gate, right? At the top of the gate, this one, ito yung gate natin sa right side. So let's solve the hydrostatic force. So hydrostatic force, F sub 2. The specific weight times H bar times area. F sub 2 is equal to specific weight 1 times 62.4 pound force per feet cube times H bar, which is 2 feet, times the area of the gate, that is 4 times 5. So ang ating hydrostatic force at point 2 is 2496 pound force. Okay, next is the location of F2. Ganun pa din, using E BH cube over 12 area times H bar. Base niya is 5. Height niya is 4 feet. Cube 12 times area 5 times 4 times H bar na 2. The value of E here is 2/3. So let's have a separate free body diagram on the forces acting on it. So first, for this force 1 or the hydrostatic force 1, this is 7 feet. This one, okay, so this is the value of F. So this is E, right? So H bar natin, magte-take tayo ng moment at point N. This N. So kukunin lang natin yung shaft torque or the moment at N. So from point N, the value of F here is since this is 7 over 2 CG, 7 over 2, 3.5. So that is 3.5 minus 4.4298. So magiging 3.0702. Okay? So yun. So next is yung ating free body diagram dun sa left side, right side. This is 2 feet. Ito, 4 feet, sorry. So, ang N natin is pa ganyan. So, ang force natin dito is and yung N natin is pa ganito. F1, F2. This is CG. Again, this is force 1, this is force. This is 4 feet. The value of this X from N is 4 divided by 2 is 2. 2 yung CG minus the 2/3. So 2 minus 2/3 is 4/3. Gets pa ba yun? Bakit naging 4/3? Tsaka ito 3.072.
Yes po, sir. 4 minus 2/3 po.
Okay. So let's take moment at point N. Ang hinahanap pala natin is yung N. Okay? Yung N ang hinahanap dito. So summation positive counterclockwise summation of moment at N equal to 0. So ano yung magiging positive dito? Ang reaction ng F from point N is counterclockwise. Okay? Ang reaction ng F1 sa N is clockwise. Of course, yung N is positive. Okay. So, unahin natin yung positive which is F2 kasi counterclockwise siya times yung ating lever arm niya which is 4/3. May minus yung ating F1 kasi clockwise siya. And then yung lever arm niya is 3.0702 from N. Next is N is positive. F2 natin is nakuha natin 2496 times 4/3. Hindi ko na nilagay yung units ha. F1 is 20,000 ito. 748 times 3.0702 plus N. And you will get N equal to 60,372.509 pound force feet. So, ito lang yung moment at point N. Okay, my question here is, bakit ko nasabi na yung N is pa left side? Because the first one here, as you can see, is mas malaki yung hydrostatic force since the water is higher level. Mas malaki yung pwersa dito sa water. So, kailangan ng konting tulong ng N para ma-counter yung force 1. Since yung force 2 is lesser than force 1. So, yung N natin is pa left side to counter the force 1 since maliit lang yung force 2. So, yun, pa left side yung N. As you can see, F1 is 20,000. F2 is 2496 lang. So, kailangan ng N 60,372 to counter F1. Okay. This one, I will be giving this as your problem set. So, merong tayong gate na triangular but in the real practice, hindi naman siya, wala naman ako nakikitang triangular na gate. Merong circular lang at saka rectangular lagi. So, tapos na tayo doon sa plane. Let's solve the curved planes on hydrostatic force. So, for curved planes, meron siyang dalawang forces to solve the curvature. We have the force at H and hydrostatic force at V. So, this is a combination of buoyancy and hydrostatic force. So, to find the value of F here at the curvature, kailangan muna natin isolve yung F of X, which is equal to F of H, and F of V, or the vertical forces, which is equal to the force above and the force below of the curvature. So, pag kukunin natin yung three-dimensional drawing for this one, ito na yon, ang rectangular. So, this is what we call F of V, or the force of this liquid na naka-rectangular. And the force of this liquid na quarter circle. Okay? So sa buoyancy, ang formula natin sa weight or force is the specific weight times the volume, right? Naalala pa to? Specific weight times volume. So, ganun din yung pag-solve natin sa F of V and F of W. We need the specific weight of this liquid and the volume of this liquid. Since this is rectangular prism, that is just length times width times height. Again, same din dito sa curvature or sa quarter circle. That is the volume of quarter circle is 1/4 of the area of the circle times the height. So, malalaman natin sa ating succeeding examples. So, F of X natin is just the rectangular part ng gate. So, this one. So, that is just the force on the rectangular part of the curvature gate. So, again, we need to analyze the curvature sa kanyang vertical at saka sa kanyang dito sa kanyang rectangular. So, F of X is equal to 0. Therefore, F of X is just equal to F of H. So, same lang yung F of X sa F of H. Since may counter dito na F of X and F of Y is countered by F of W and F of V. Okay? So, therefore, F of Y is equal to a summation of forces downwards positive, right side positive. So, pag positive tayo, positive yung, tama ba? Ang F of H natin is positive. Ang convention pa natin dito is pa left side. So, yun. Ang positive dito is, ay tama nga. Ay, ang F of H is minus since pa right side siya. And yung F of X natin is pa left side kaya nagiging positive. So yun lang. Hindi naman siya importante kaya masyado dito. Ang F of X naman, ang F of Y is the summation of forces of F of V and F of W. So that is the total F of Y. The force of the F of V and F of W. Minsan din wala na tong F of V because yung gate is nasa pag ang gate ay nasa ano na, nasa surface. For example, this one. I-drawing natin. For example, yung gate is ganito na, nasa surface na. So, ang isa-solve lang natin is f of w. Wala nang f of v. Okay. Next, pag nakuha natin yung f of x and f of y, kailangan natin siyang parang Pythagorean theorem lang to. So, that is f of x and f of y. To find the f, this one, kailangan nating Pythagorean theorem. So, f of x squared plus f of y squared. So, that's how you find the total hydrostatic force on the curvature. So, medyo complicated lang dito na part yung curvature. Since we analyze it using the horizontal and the vertical forces. Okay, start tayo ng example para mas maintindihan. Okay, so the tank is 3 meters wide into the paper. You mean 3 meters wide into the paper. If you're seeing my screen, you need to project 3 meters wide. Okay? So, 3 meters wide. Okay? So, yun lang. You need to project 3 meters wide. Neglecting atmospheric pressure, compute the hydrostatic force on the horizontal, vertical, and the resultant force. So, this is the resultant force for the curvature. Okay? On the quarter circle panel, BC. So, this is a curvature gate. So, nakikita nyo yung sa previous na pinakita ko sa inyo, yung meron ding curvature na design doon sa dam. So, yun. So, first is we need to find f of x and f of y. So, hindi naman sinabi na naka-hinge yung C and B. Hindi pa yun ha, wala pa tayong hinge. Hydrostatic force pa to. So, let's try to find first f of h. So, f of x summation equal to 0. So, gawin ko na lang positive at the right side. So, we're in f of h natin. Ito yung f of h to be countered by f of x. And f of y, this one, to be countered by f of v and f of w. Okay, so f of x is just a summation of x at the horizontal axis wherein ang f of h natin is positive and yung f of x natin is minus. Ganun lang din, f of h is equal to f of x. How to find the f of x or f of h? Since pareho lang sila. Ganun din, we need to analyze that one, yung kanina nating process on solving it. So, again, if we analyze this curvature gate, magkakaroon siya ng rectangular gate at saka yung upward forces. So, sa f of h, we need to analyze it doon sa kanyang edge or dito sa kanyang left side. This one. So, we see it as a rectangular gate dito sa f of h. So, this is f of h. So, find the h bar. So, since f of h is equal to specific weight times h bar times the area of the rectangular gate. Again, yung f of h natin is naka-rectangle. Ganito kasi yan sa 3D. Okay? So, this is the force at the f of h. So, naka-rectangular yung we see it as a rectangular gate. Hindi pa dito sa curvature gate. So, yun. Next is the specific weight. That is water. 1 times 9.81. But we need to have the h bar and the area. So, ano yung width ng gate na to? So, we need to project 3 meters. So, this is 3 meters. The height is 5 meters. This one, 5 meters. Okay. So, h bar is from the surface to the centroid. So, therefore, h bar is, kukulayan natin. Uh, this is 4 meters, tama? 4 meters. 4 meters plus half of 5, that is 6.5. Okay, so okay, that h bar is 6.5. Area is 3 times 5 since that is rectangle. F of h is equal to uh, or f of x, the same lang, that is 956.45 or 475 kilonewton. Next is yung ating vertical forces. So vertical forces acting on the gate, positive 0, positive pag downwards. Yung vertical forces natin is f of y is negative. Ang ating positive is just f of v kasi pababa. Ang f of w is pababa din. And yung ating f of y is pataas. So therefore, f of y is equal to f of v plus f of w. Okay, so yung sinasabi ko, kukunin natin yung 3-dimensional dito ng rectangle plus the quarter circle. Okay, so this is the rectangle and this is the quarter circle. So to find f of v and f of w, may formula tayo doon sa ating buoyancy, that the weight is equal to the specific weight times the volume. So this is f of v, this is f of w, right? So that is the specific weight of this water na naka-rectangle times the volume of that shape. Okay? This is length times width times height. Plus f of w, that is the specific weight of this quarter circle liquid times the volume of the quarter circle. So this is ay factor out na lang natin yung specific weight. So volume ng rectangular prism is volume ng quarter circle. Ano bang volume nito? Length times width times height. Volume ng quarter circle, that is 1/4 by r squared times height or times the width. Diba ang area ng circle is pi r squared? Since this is 1/4, kaya 1/4 times width kasi volume. Area pa to, diba? Based on the dimension, this is 4 meters, sorry. And this is 3 meters wide. Then this one is 5 meters. Ito, 5 meters, 4, tapos 3 meters wide. Gets yun? So this is 4 times 3 times 5. Arrange natin. So this is 5 times 3 times 4. This is 5 meters, 3 meters wide, and the height is also 5 meters. Ano ito? 5, then the width is 3 meters. So this is, ang kailangan lang naman niya is yung radius, which is 5 meters. Diba ito yung radius, 5 meters, 5. So V niya is 1/4 pi times 5 squared times W, which is 3. Gets pa dito? So, lagay natin sa equation. Specific weight ng tubig, since same lang ng tubig nito, that is 1 times 9.81 kilonewton per cubic meter, right? Times the volume of the cylinder, rectangular prism, that is 5 times 3 times 4, plus the volume of the quarter circle, that is 1/4 times pi, 1/4 pi times 5 squared, the radius squared, times the width, 3. So f of y natin is equal to 1166.457 kilonewton. Okay. So, ang f of y and f of x is, di ba equal lang tong f of x and f of y, h. So, mayroon na tayong horizontal forces and vertical forces. Makukuha na natin yung resultant F or resultant hydrostatic force sa gate using Pythagorean theorem. So this is F equal to the square root of F of y squared plus F of y x squared. 116.457 squared plus 956.475. Shit. Okay, so the value of the hydrostatic force, this one, on the curvature gate is equal to 150.8.465. So that is the summation of f of x and f of y by Pythagorean theorem. Okay, next is yung direction niya. Okay, yung direction niya, if we try to solve this one, dito din natin. So this is f of h, f of x, is f of y. So kailangan natin yung direction. Ay. Yung direction niya is naka-angular since siya ay naka-angle. So that is tangent theta equal to opposite, tama ba? At yung angle pala niya is dito. Okay, that is f of y over f of x. So yung location na lang dito ng f niya. 'Di ba yung location niya mahanap natin pag rectangular or pag straight lang is value ng e, dito is using using trigonometry or the angular distance. So this is f of y, which is 1166 ay 0.457, and yung f of x is 956.475. So tangent theta equal to equal to 50.6 degrees. So that is the location of the hydrostatic force. 50.6 from the horizontal. Okay. So that's how you locate the value of f pag curvature. Hindi siya magdedepende sa value ng e since naka-angular nga siya, 'di ba? Okay. Okay, let's try to have another problem pero hindi mo na natin idagdagan ng hinge. Okay, next. So, hindi ko pa siya na-try to. But, let's try to neglect first the hinges since magkakaproblema tayo dito pag hindi pa natin master to find the value of F pag naka-curvature ang gate. Okay? So, gate AB is 7 meters wide into the paper. Again, if you project 7 meters wide sa screen ko, magkakaroon ng ganitong mukha. 7 meters. Compute the force required to prevent the rotation at hinge B. Again, bukas natin isa-solve yung mga hinges. So, pag may hinge yan, may support ng horizontal B sub X and vertical na B sub Y. So, bukas natin isa-solve ng pagganito since we need to master first to solve the value of the hydrostatic force on the curvature part of the gate. And hindi ito quarter circle ha. Ito ay parabolic gate. So, magkaiba yung parabola sa quarter circle. Okay, so first is we need to find the f of h. So, f of h is countered by f of x. So, therefore, f of x is equal to f of h. So, since the gate is on the surface of the water, so wala na tayong f of v. Meron na lang tayong f of w. So, this f of w or the weight of this parabolic gate will be countered by f of y. So, summation of f of x equal to 0, positive yung f of h. Positive on the right side, therefore, f of h is positive minus f of x yung nasa left side. So, therefore, f of x is just equal to f of h. And how do we find f of x and f of h? Using the ordinary way on how to find the hydrostatic force na naka-rectangle. Since nasa surface siya, so ganito, dito yung f of h. So this is 6 meters. Right? 6 meters. And this is 7 meters wide. Okay, so ang ating h dyan, h bar is 3 meters. That is the distance from the surface to the centroid of this rectangular gate. I have pala no? Kasi nga, 9.6 pala to. Di pala to 6. Or, di na makita eh. 9.6 meters. So therefore, that is 9.6 divided by 2 equal to 4.8. So let's find first the hydrostatic force. F of x is equal to specific weight times h bar times the area. This is water, tama? 1 times 9.81 times h bar, 4.8 times area of the gate na naka-rectangular, 9.6 times 7. So f of x therefore is 3,164.314 kilonewton. Okay, next is yung ating f of y. Summation of y equal to 0. Positive lang ating downwards. Okay, so f of y, f of w is positive, f of y is negative kasi pataas siya. So f of w is just equal to f of y. Okay, how do we find f of w? Using the volume. Okay, kunin natin yung, again this is parabolic gate. So the height is 9.6. This one is 3 meters. And this one here is 6 meters, right? 6, 9.6, 7 meters wide. So the formula for parabola, area of parabola kasi is 2/3 base times height. Therefore, the volume is just 2/3 times base times height times the length. Right? So, F of W is specific weight times the volume of the parabola. F of Y is equal to specific weight 1 times 9.81 times the volume of the parabola, 2/3 times base times height times length. F of Y is equal to 1 times 9.81 times 2/3 times base, that is 6 meters, times height 9.6 times the length or the width is 3 meters. So F of Y natin dyan, or just the F of W, equal to 2636.928 kilo Newton. Next is to find the total hydrostatic force by Pythagorean theorem. So this is the F, this is F of X, this is F of Y. So that is F equal to the square root of F of Y squared by Pythagorean nga. Squared. F there is equal to 2636.928 squared plus F of X 3164.314. Ano ba oras na? Okay, so this one is wait. Square root of 2636.928 squared plus 3164.314 squared. So the value of F sa curvature is 4119.014 kilo Newton. And yung location niya sa location niya ng F is naka-angular, so that is tangent theta so that is inverse tangent F of Y 2636.928 over 3164.314. So that is the location of the hydrostatic force. So that is tangent theta equal to 2636.314. So that is 39.806 degrees from the horizontal. Okay po. So again, for curvature part ng gate, pag curvature yung gate, yung kanyang position is naka-angular. So hindi siya katulad dun sa vertically submerged na gate wherein we need to find the location of force sa value ng eccentricity. So, yun. Yun yung pagkakaibahan ng curvature gate sa vertical gate. Nai-gets yun? So let's have a break first and then we solve another problem. Dagdagan natin ng hinge yung ating gate. So katulad kanina, yung solve natin, we applied the We include the hinges or mga support ng hinge A sub X and A sub Y. So applicable din doon sa curvature. So mas more complicated pag naka-curvature. Okay? So let's have a break and then magcha-charge pa ako para hindi maging static yung voice ko. Okay yun?
Yes.
Sino natapag? So balik tayo mga 9:10. Hello, good morning. Napapakinggan ako. Okay, so tatapusin lang natin tong hydrostatic force ngayon. So, let's solve the curvature gate na mayroon na siyang mga hinges. So, let's apply it. So, kanina sinolve lang natin yung hydrostatic force dun sa curvature gate. Ngayon, dadagdagan natin ng hinge. So, sabi niya dito, yung original problem, that we need to compute the force F, this one, this F here, to prevent the rotation about the hinge B. So, meron tayong hinge B. So, again, yung hinge B, meron dalawang forces support the weight of this hydrostatic force, that is B sub Y and B sub X. Then yung F. So, we need to find the F. So, since meron value na tayo ng F of X and F of Y, ang aalamin na lang natin yung location nila both. Okay? So, since ang F of X, we analyze it using the rectangular or the vertically submerged na hindi pa na okay. Vertically submerged na object. Naglo-load yung aking PowerPoint. So, we solve its location based on E. Okay? So, this is F of H or F of X. So, using E, malalaman natin yung location niya. Since magkakaroon kasi tayo ng moment mamaya, and ang lever kasi magdedepende sa location ng F. So, we need to take moment at point B para makuha yung force F. So, ang location ng F of X is BH cube over 12A H bar. So, E is equal to base is 7, H is 9.6 cube over 12 times the area of the rectangle, since we are analyzing first the rectangular part of the curvature, that is 9.6 times 7 times H bar, which is 4.8. Teka lang nga, naglo-load ang aking teka lang. Excuse. Paano ba ito? Bakit naglo-load pa siya? Nag-load kasi yung PowerPoint. Kita na po yung screen. Okay, again, we just solve the value of E sa f of x or sa f of h, where it is the part of the curvature. Yung x-axis niya is the f of h. Okay? So, ang location ng f of x or f of h is 1.6 from the centroid of this rectangular gate. So, next is the centroid of this f of y. So, how do we find the centroid of the parabola? So, this is the formula for the centroid of the parabola. Bakit kinukuha natin yung centroid dito? Since dito, yung ating E is yung ating location ng F is doon sa center of pressure, sa vertical naman is doon sa centroid. Kung naalala nyo yung sinabi ko last time sa pressure, if ang ating object is parang naka horizontal na submersion, the F will act at the centroid. Pag naka naka vertical, the value of F will act at the center of pressure or below the center of gravity. So this is the parang f of x and f of y. To find the location of f of x, siya ay nandun sa center of pressure, wherein the distance of center of gravity and center of pressure is E. Kaya kinukuha muna natin yung E. The location of this f of y is centroid ng object, wherein that is horizontally submerged. So centroid of parabolic, this one. So that is the explanation of how we need to find the location of f of x and f of y. The centroid ng parabola is formula of which is x equal to 3/8 of the what we call this as the width. Base na lang. Base, okay? 3/8 of the base. That is the centroid at the x. Okay, so this is 3/8 over 6, since this is 6 meters, right? So this is our x here is 2.25. Yes. So alam na natin yung location ng f of x and alam na natin yung location ng f of y. So let's draw the free body diagram for this one para mag-take ng moments tayo. Okay, so this is our b sub y. Ito. This is our b sub x. This is our gate na 9.6 and yung f of h is nandito, right? Or f of x, same lang sila ng value. And yung f of y natin is nasa centroid nito. Magets pa ba? Yung f of x is magte-take tayo ng moment sa b. So this is centroid ng 9.6. So that is 9.6 divided by 2 minus the e. So therefore, yung f of x natin or f of h is 3.2 from b. Okay? Since ang e natin is 1.6 and this is half of 9.6. 9.6 divided by 2 minus 1.6. Ang f of y natin naman is 2.25 from B. Okay. So let's draw the reaction o ang rotation niya. Ang rotation niya, f of x sa B is pa counterclockwise. Ang f of y naman natin sa B is pa counterclockwise. And nakalimutan natin yung f. Ang f naman natin is wait. Letter B. Ang f ay nandito. So yung hinahanap kasi is 9.6 from the B. Okay? So ang rotation naman niya from B is counterclockwise. Tama, counterclockwise. This is clockwise, this is clockwise, this is counterclockwise. So let's take a moment at B. So summation of moment at B counterclockwise is positive, equal to 0. So magte-take tayo ng moments at B because hahanapin natin yung force F required to stop the gate when there is an hydrostatic force equal to the resultant force of f of h and f of y, or f of x and f of y. So ano yung mga forces? This is f of x, that is negative because clockwise f of x times 3.2 from B. Next, ang f of y naman natin is negative ulit dahil clockwise siya, and from B that is 2.25. So that is f of y times 2.25. Lastly, yung unknown natin is positive kasi counterclockwise siya, plus f, and location from B is 9.6. 0. So we do have values for this one. Sinasolve natin. F of y is 2636.928 times 2.25 plus, ito yung hinahanap natin na F. Hindi ito hydrostatic force ha. Ito yung F required to stop the gate. Okay. So, using calculator, you will solve F equal to 1672.801 kilonewton. So that's how you solve a curvature gate pag nilagyan natin ng mga hinge pa. Okay. Do you have question on why I arrive at 3.2? Kuha to, bakit naging 3.2?
Gets po.
Okay.
0.6.
Sige. So hanggang dito na lang muna tayo, and then may susunod pa naman tayo na lesson, pero I don't want you to be overwhelmed with this lesson since ito yung pinaka-complicated na lesson natin sa hydrostatic force. And mind you, this is your first topic on your fluid machinery for the mechanical engineering. So sa next time meron kayong fluid machinery, then ito yung magiging lesson nyo, yung computation of the hydrostatic forces on dams. So kaya pinapractice ko na kayo. Ito yung parang foundation nyo doon sa inyong sa susunod na prerequisite ng subject na to, which is fluid machinery. So ganito yung lesson nyo doon. So sa naval architecture naman, ang susunod na subject namin sa fluid mechanics is yung motion in waves. So hindi na kami magtatakil ng mga ganitong problems usually. So for mechanical engineer, advantage kayo pag marunong na kayo mag-solve ng hydrostatic forces and the forces na nasa hinge natin, or yung mga forces na nagsusupport sa gate. Okay, so hanggang dito na lang muna tayo. Then tomorrow we will have another the last the topic, hindi pa naman last pero next topic na tayo, which is the fluid flows. Simple fluid flows, then dadagdagan natin ng turbines and pumps, and then also we need to provide it with friction and head losses. So yun yung ating last topic. So next this week I will finish all the coverage of the finals. Then on Monday next week we will have our second quiz or the last quiz. And then on Friday next week, or hindi ko pa sure kung kailan yung finals natin. Again, ina-advance ko na kayo na mauuna yung final exam natin para if ever merong magre-removals, then we could proceed it before the submission of grades. Kasi uuwi din ako ng Cebu City after ng 24 something. So, kailangan ko mag-advance ng final exam. So, rest assured naman na matatakel natin buong chapters ng fluid mechanics. So, if you don't have any other question, I will be sending this PowerPoint with annotations sa GC ulit. Do you have questions?
Wala naman po, sir.
Okay. Okay, yun na lang. Tomorrow, another topic ulit tayo. So if you don't have any other question, then see you tomorrow and thank you for listening, guys.
Thank you po, sir.
Thank you po. Thank you po, sir.
Thank you po, sir.
Thank you po, sir.